We have seen different rays of light which are falling on a concave mirror. What happens to their resultant or final fate? A parallel ray to the principal axis passes through the focus. A ray passing through the focus becomes parallel. Any ray of light along the center, after reflection, it is incident normally. After reflection, it returns back in the same path but in the opposite direction. Now we will take a convex mirror. What is a convex mirror? You just see the rear view mirror in vehicles, especially two-wheelers. There will be a mirror and you can see that, you can touch it. It always reflects from the outer surface, convex surface. So suppose you take a convex mirror. How do we represent a convex mirror in the diagram? It will be like this. So you will have a convex mirror like this. Again you see, its inside part is silvered, painted. Outside part is reflecting. So I represent it like this. I always take the reflecting surface towards the which is looking towards the left hand side. So it is looking towards here. For example, concave mirror, its reflecting surface looking towards the left hand side. So that rays of light will come from left side to the right side, that is along plus x axis. So if you take a convex mirror and incident, similar paraxial rays. Of course, sir, whether convex mirror has got a center, whether it has got a pole, yeah, definitely. If you take a convex mirror and it is also a part of a sphere, I will make it a sphere like this, yes, it will have a center here. And there is a geometric center for the convex mirror also. The geometric center of the convex mirror is called pole because we want to have a reference from where all the distances have to be measured. So geometric center of the mirror is called pole. Again, the same definition holds good. And the line joining the pole and the center is called principal axis. Remember, it is a line joining the center and the pole, and it is not having a definite length. But what is the distance between the center and the pole? And that is called radius, like this. Now we will study the same rays. What happens to the same rays when they are incident on a convex mirror? If you take parallel rays of light, paraxial rays, when they are incident on a convex mirror, when paraxial rays are incident on a convex mirror like this, how do they get reflected? Again, they must follow the angle of incidence equal to angle of reflection, the first law of reflection. They must follow. Sir, at what angle of incidence this is? Now, I will rub this other part of the convex mirror which is not needed for us. It is just an imagination that it is a part of a sphere. So the outside part of the rear view mirror, that is convex mirror, a ray of light is incident at some angle like this. It is a paraxial ray, it is parallel to the principal axis. At what angle it is incident? If you want to know at what angle any ray of light is incident, we know in a plane mirror, if the ray is incident like this, draw a normal and measure the angle with respect to the normal. Sir, how to draw a normal here? Again, the same rule. If this is a part of a sphere, it will have a center. Join this point and the center. This should be the normal here. This line is the normal here. So this is the normal because that passes through the center. So what is the angle of incidence now? Definitely this is the angle of incidence, I. Angle between incident ray and the normal. That is angle of incidence. Ray of light follows the law of reflection. Here also, no problem. And it should get reflected in the same angle. That means I choose an yellow color for incident ray and reflected ray will follow like this. So that angle of incidence is exactly equal to angle of reflection, R. See how easy it is to trace the ray in a plane mirror. A ray of light like this, normal, angle of incidence, angle between incident ray and normal, angle between reflected ray and normal, that is angle of reflection, I equal to R. Here, ray of light incident parallel to the principal axis, but for the mirror, curved mirror, it falls at some angle. If you want to know that angle, join the line to the center, that acts like a normal. This is angle of incidence, incident ray and normal, gets reflected in the same angle on the other side. So angle between normal and reflected ray, angle of reflection. What about this? That also follows the same path. Same rule. So draw a normal here. I have used pink color for normal. Okay. Join this towards the center and like this ray of light should get reflected at the same angle, okay, little like this, right, and this is angle of incidence for this is the angle of reflection. Now for a person observing from here, if all these rays and come like this, and if a person is observing all the reflected rays, person can't see these rays, they are moving out of him and he is receiving all these rays, reflected rays. He feels that these rays are coming from a point here, and this point is called focus. See the difference in focus, finding the focus in a concave mirror and convex mirror. In a concave mirror, if paraxial rays are incident, they actually meet at a point, and that point is called focus. Whereas in a convex mirror, if parallel rays are incident, they diverge. They don't converge as they do here. They diverge here. But when they diverge, they don't diverge randomly. They diverge in such a way that they appear to come from this point F. So they appear to diverge. Try to write this word always in the exam. Appear to diverge from a point inside the mirror. So a person observing these two rays of light, he feels that these rays of light are coming from this point, a point here, and that point is called focus. So when you write the definition for focus in the examination, you have to include both. When paraxial rays are incident on a curved mirror, maybe concave or convex, anything. When paraxial rays are incident on a curved mirror, after reflection, either they meet at a point or they appear to diverge from a point on the principal focus, and that point is called focus. In a concave mirror, they meet at a point. In a convex mirror, they appear to diverge from a point. From here, they appear to moving away. So that point is called focus. Then your normal definition, what is focal length? It is the distance from the pole to the focus, as if we measure here, and everything goes in the same way. So focus is a point where when paraxial rays are incident on a mirror, after reflection, either they converge or appear to diverge. So this word, better you study this. So you should have some words in your brain. You should have a small dictionary in your brain. Add these words to your dictionary so that the answers become very beautiful. So appear to diverge from a point, and that point is called focus. Now, so suppose, sir, how to incident a ray of light? Normally on a convex mirror. Okay, this is a convex mirror. It's a part of a sphere. Of course, these dotted lines you need not draw. There should be a center, and there should be a focus. Okay, and this is the pole, midpoint of the whole geometrical area. How to make a ray of light incident on a convex mirror? So you go and see the rear view mirror in a vehicle. It will be put like this, and you have to make a ray of light to incident on the rear view mirror, and it should reflect back in the same path but in the opposite direction. How to do so? Select a ray of light which is moving towards the center, because you know any ray which is along the normal should be towards the center. So first of all, join this center. So take a ray of light towards the center. Definitely it doesn't enter into the mirror, it gets reflected back in the same path but in the opposite direction. So this is the normal incident ray. Whereas normal incident ray for a concave mirror is, a concave mirror reflects from the inside part, as you know. This is focus, this is center, and you know any ray of light along this center gets reflected back. So you must be very aware of all these rays of light. You must know what happens to such and such a ray immediately. Otherwise you can't trace the rays of light, trace the image. Okay, so this is the normal incident ray here, and this is the normal incident ray here, which is along the center. And again, any ray parallel to the principal axis, of course I'll rub this. Any ray parallel to the principal axis appears to diverge from the focus like this. So it reflects in such a way that it appears to come from focus. Sir, now if I take a ray of light along the focus like this, okay, if I incident a ray along the focus onto the convex mirror, what happens to it? Definitely it moves parallel to the principal axis like this. So any ray along the focus moving towards the focus, after reflection emerges parallel. It's a reversible case. So these are all the ways in which the rays move, and we are very much acquainted with all these rays. We know what happens to all these rays. So they help us a lot in tracing the image. Now, when we trace the image, when the images are formed, we should follow some sign conventions. So which distance has to be taken in what way? How to get the final image, whether it is erect, whether it is inverted, how to notice whether it is erect or inverted using the answers that we obtain, and these how to retrace them, all these things are given in sign conventions. Of course, this is a very important part, and when you study this first time, you should put a print in your brain in a proper way when you study this for the first time. Suppose you get confused when you print all these conventions in the first time itself, you will find it difficult to repair it. So once it gets printed in your brain, it should be a correct print. What are sign conventions? Sign in the sense plus sign and minus sign. Convention means what do we follow? We drive our vehicle in the left side of the road. That is our sign conventions. So that makes the traffic better, right? Less confused. So similarly, we have sign conventions in the formation of images. Whenever a mirror or a lens forms the image, receives light, makes the light to undergo reflection or refraction, image is formed and we get focus, and so many types of phenomena involved here. For example, I take a concave mirror which reflects from inside. And this is the pole, geometric center is called pole, and the center of curvature, if you complete this as sphere, you will get a center, and if you incident parallel rays of light, they meet at focus, and this is called focal length. Now, first sign convention. Okay? First sign convention is all of us should follow the same method throughout the world. What is that? Measure all the distances from the pole. What is radius of curvature? Distance from pole to center. What is focal length? Distance from pole to focus. Everything is started from pole. Suppose you say such and such a town is at 75 kilometers. What do you mean by that? From your reference point. Your place is the reference point. From here 75 kilometers. From here 100 kilometers. From pole of the mirror. Every time you have to measure it from pole of the mirror. So all distances are measured from the pole. This is not over. All distances are measured from the pole. But how do you measure it? For example, suppose you have an object here. Suppose you have a small bulb switched on here. And if I want to trace where is the image of this bulb, what to do? Don't measure the distance like this. Measure the distance parallel to this. That means this is the distance, not this one. So all distances are measured from the pole parallel to the principal axis, like this, not like this. So parallel to principal axis. I'll write principal axis PA for the timing. I'll save the time. All distances should be measured from the pole parallel to the principal axis. Sometimes you need to measure it from other side also, so that is also allowed, either from here or here, but let it be parallel. Suppose you have an object here, don't measure it like this, measure it like this. Pole to center, pole to focus, okay, let it be. If the object is somewhere else, measure it like this, parallel to the principal axis. All the distances are measured from the pole along the principal axis, parallel to the principal axis. Okay, what is the next sign convention? So when you start from the pole, start measuring the distance like this, or sometimes you need to measure the distance like this. So you may go either on this way or that way. In what direction you go, that gives the convention. For example, I'll rub this also. Okay. Right. Suppose this is a concave mirror and I place center, it's the center of curvature, focus where parallel rays meet. Now suppose I have an object here. Suppose I have an object here. Suppose the image is formed here. an image is formed here inside the mirror like this. Sir, how do we measure the distances? We call this distance as the image distance, V, and remember in the first year you had U means initial velocity, V means final velocity. Forget it. Now U is object distance, V is image distance. In this chapter, U is object distance. Where is object? Object is here. So measure along the principal axis. Now, how do you record these U and V? Shall we put both U and V in the positive values or negative values? That is a sign convention. See, how do you measure the object distance? You have to follow this first. All the distances are measured from the pole. Start from the pole. Now, if this is a bulb, how does the bulb emit the rays of light? Like this. Bulb emits the rays of light from it diverging and going away. It comes like this. When you are going to measure the distance from pole to the object, you move against the direction of light. Any distance measured by traveling opposite to the direction of light is taken as negative. Distances measured opposite to the direction of light are taken negative. So in this case, U is negative. Right? I will keep on explaining this, okay? You will have lot of confusions in between. But after reaching certain stage, after solving some problems, after applying all these sign conventions here and there, every doubt, one by one will get cleared. You will have a lot of doubts in your brain in the beginning. Distances measured opposite to the direction of light are taken negative. Now, when you measure the image distance, what you will do? You will start from the pole. So pole is here. Where is the image? You have to move like this, right? So you have to measure the distance from the pole to the image. So you have to move like this and measure the distance. Now V is positive here. So how do we write this? What is the second convention? Distances measured along the direction of light are taken positive, and distances measured opposite to the direction of light are taken negative. That is the simplest convention. Shall I write it? Distances measured along the direction of light are taken positive. I will write only this one. Of course, you will get this in books. You can refer any book. Are taken positive. And you have one more book called NCERT book. Please refer it. And usually people purchase NCERT book, keep it somewhere else. You read it. But once you listen to somebody's class, go and once you understand some things related to the topic, go and open the NCERT book, read it. Everything is narrated like a story, and you will start understanding the story little by little. So you have to listen to your class and then start reading it. You will get so many things. They narrate so many ideas, so many ways of presentation. So please read it, and you will get all the sign conventions there. Distances measured along the direction of light are taken positive. Along with that, distances measured opposite to the direction of light are taken negative. Of course, all these sign conventions may be made very easy when you apply to a problem. Because I have told, every time observe when I draw the diagram. I always keep the mirrors like this so that object is on the left hand side, and always I keep the opportunity of ray of light traveling from the left to right. I don't keep a mirror like this, and I don't draw any mirror like this. Of course, if you keep a mirror like this, is it wrong? No, never. It is. Mirror doesn't know whether it is kept towards south or east. It always forms the image. But for our convenience, better to have diagrams like this, so that sign conventions become very, very easy. So, distances measured along the direction of light are taken positive, because light is traveling like this. Light from the object, that is the reference. Light from the object is traveling like this. Of course, it is hitting the mirror and coming somewhere like this. That is a different case. Light from the object is going like this. So how do you measure the image distance in this case? It is along the direction of light, starting from the pole like this. So that is taken positive. Distances measured along the direction of light are taken positive. Distances measured opposite to the direction of light are taken negative. Now, suppose you get an object and image like this. If this is a mirror, and this is the principal axis, line joining the center and pole. Every time I repeat that definition so that it becomes little familiar. And suppose there is an object here, and if I get an image here, so this is object, this is image. Suppose if I hold a candle flame here, suppose the inverted image of the candle flame is formed here. This height above the principal axis, I call this as height of the object, and height of the image, okay, let this be somewhat smaller, let this be smaller, like this, okay. So this is the height of the image. Height of the object is taken positive, height of the image is taken negative. Why? All the heights, vertical heights, height should be vertically measured. All the vertical heights above the principal axis, it is y-axis, remember, this is y-axis. All the vertical heights above the principal axis are taken positive, and all the vertical heights below the principal axis, minus y-axis, are taken negative. Height of the image is below, because you have to start from the principal axis. So heights measured above the principal axis, that is along plus y-axis, are taken positive, and heights measured below the principal axis, that is along minus y-axis, are taken negative. So shall I write the third one here? I will write only one, the other one you have to write it yourself. Heights measured above the principal axis, heights measured vertically and above the principal axis are taken positive, and of course heights measured vertically below the principal axis are taken negative. Of course this can be made very easily. What you have to do is take a concave mirror, you place the concave mirror in such a way that ray from the object travels along plus x-axis. Divide this into two coordinates like this when applying. Suppose this is a question for 3 marks, don't explain it like this. If it is a question for 3 marks, write the 3 sign conventions. Not a very important question, but may be asked. Write the 3 sign conventions, and while dealing with derivations, while dealing with problems, you can do like only like this. Take a mirror, take a lens, divide it into 4 coordinates, Cartesian coordinate system. Everything that comes in the right hand side is positive, everything that comes in the left hand side is negative, everything that is in plus y-axis positive, minus y-axis negative. Finished. That becomes very easy, provided light ray travels along plus x-axis. Suppose you reverse it, everything gets reversed. So this is the reference that we take. So every time when you draw the diagram, you follow this rule. So the 3 sign conventions used in the reflection are, even we use it in refraction also. All distances are measured from the pole of the mirror along the principal axis, parallel to the principal axis, and distances measured along the direction of light are taken positive, distances measured opposite to the direction of light are taken negative, and heights measured above the principal axis vertically are taken positive, heights measured below the principal axis vertically are taken negative. So these sign conventions we have to follow every time. Okay. How many lists are there?